Thank you everyone for joining and for making time. And if you're watching the recording of this, thank you for listening in. Today's session is hosted by Platform 9, and we have Union and Run, both participants in the AI and ML space, and I will let them introduce themselves really shortly. During this session, we're going to jump into infrastructure ROI, some of the challenges around running AI and ML workloads in the cloud and on-premise, and why people might be doing that, as well as other topics that come up through the audience and things that are happening, sort of current in the industry right now as well. With that, I'm going to jump into introductions. I'm going to let Haytham introduce himself.
Right. Thank you, Chris, for the invite and for organizing all of this. My name is Haytham Abou-Ftoua. I'm one of the co-founders and CTO of Union, and one of the authors of Flight. Hopefully we'll get to talk about the workflow orchestration in a minute.
Excellent. Thank you for joining.
I guess I am next. So yeah, thank you so much for inviting me, and great for it. Thank you for setting this up. So my name is Gijsbert Jansen van Doorn. I'm the Director of Technical Product Marketing at Run AI. And Run AI is kind of a platform that allows AI practitioners to get access to compute resources in a very, very efficient way. I think that's definitely a key part of the topic that we're going to discuss today, and I'm really happy to be here.
Excellent. So people might be wondering how Platform 9, Run, and Union sort of come together. When I look at the marketplace, I sort of saw some changes happening within AI ML and where workloads are getting run, and a lot of those are containerized. And Kubernetes ends up being a great location to run containerized applications and services. And I think it was a sort of like a natural evolution that these workloads that might have been in something like a Docker Swarm have moved into Kubernetes, and Platform 9 really makes it easy to run Kubernetes. Flight, actually, when they launched, reached out to Platform 9, like 2020, 2021, Haytham?
Yeah.
As a workflow engine, right, on top of Kubernetes. Run sits like right in the middle. It's the pizza sky. I like to say it's like the thing that glues the hardware and Kubernetes together. It makes it much more functional and optimized.
I like that acronym.
So between the three of us, I feel like we've got a pretty good solution for MLOps teams, data scientists to optimize workloads, streamline your practices, and really offload a lot of the burden of doing this well from your team, so they can focus on actually running your business and not focus on running Kubernetes clusters and optimizing infrastructure and pulling together workflow platforms. Yeah.
Yeah.
I think the next question is how did we get onto this topic, and how did we get started? Not to jump on the chat GPT bandwagon, but I think that's what everyone's getting interest from these days, and they're all hearing AI. I think I saw something yesterday on LinkedIn that said there's 1,000 new AI tools / companies that came online in March alone. To me, that's not the topic, right? To me, the topic is there's companies out there that are really training models. They're running services that are becoming these 1,000 new tools. They're using compute and workloads out there. But to get there, you have to train that model. And to, I think, have a competitive advantage, you need to take a model and keep it current. Be constantly updating what you're offering out to either your business users or your customers. This is really what piqued my interest, right? VentureBeat threw it out there and sort of said, this is cool, but let's talk about how much it costs to get going. And they think it was in the millions of dollars. 560 NVIDIA A100s, that's an investment. Twitter to sport, a few thousand. The Twitter Vine, I thought the W got removed. So that sort of led me to the question, right? Well, how much is an A100? And are they available? For most of 2020, 2021, I feel like the world was told, hey, you can't get graphics cards. They're all being used to mine Bitcoin. I don't know, what did you guys feel like the industry was saying to the world?
Yeah, we definitely heard a lot of, especially from the smaller companies, that when you don't, we're not big enough to have a contract with AWS to supply you with A100 machines. You are out of luck. You just, some people went to Oracle Cloud, GCP had some. They were just like, you will get your hands on whatever you can get, and then build a tech stack on top of that.
No, we've even seen customers using consumer grade cards because they were a little bit easier to get by. And the thing that NVIDIA did well is CUDA. And they were all CUDA compliant, so they could start using them and started building clusters around more consumer grade cards. So that was definitely a shortage that was real.
that platform play, they started a long time ago. I want to say 10 plus years. And I think there's an interview that the CEO of NVIDIA did with, it was Business Week. It's on YouTube. It's actually a longer than 1 minute clip where he talks about the evolution of that platform and how, some of these workloads actually found them. And it wasn't the plan from the get-go. The A100 cards, I went on to CDW Friday and just said, hey, how much is this? This is what's on the website. I didn't make up this price. And it said 6 to 8 days for delivery. So I think this is something realistic. I don't think Elon's going to be waiting for his next round of GPUs for Twitter. So then the question is, well, if that's what it costs to buy, what does it look like in the cloud? Once again, these are list prices. There's a couple of cloud services out there that you can just hit up on Google and they'll start showing you the prices for different workloads. On demand list price for AWS's largest A100 box, that's a pretty significant figure right there. Even doing reserved upfront pricing, assuming you can get it, significant saving, but you're still making a significant investment from a business perspective. What are people using out there, right? In the field, what are you guys seeing as a common instance types that people can actually get realistically around the world in different regions and different clouds?
Yeah, we definitely see a lot of demand for the E100s and V100s especially for the training phases, right? People don't want to think about getting constrained on like compute, on GPU compute. Like they just, even if they don't utilize it as much, they would like to have the capability, and the bottleneck becomes their code, not the machine, not having to write distributed code through training and all of that. So if they can run it on one machine, they would rather do that. I think it also works out more economically if you can really get the utilization up on that one machine, as opposed to getting a bunch of smaller machines. So availability is really the biggest hurdle here.
Yeah, no, absolutely. I think A100s, V100s are the ones we see the most. T4s for like more like inference workloads, or we do see companies basically deploying a new instance for every data scientist whenever they need. I'm not saying this is the best way, but we see it happen. And then they typically go for a little bit more cost-friendly GPU type. But I think those are like the three we see the most within our customers. But availability is a big issue. We've had conversations with organizations that need to go through to different regions to make sure that they can have, let's say, A100 instances available because they weren't available at that time in that specific region they were looking for. So it becomes really complex and a pain to make sure that you always have the ones available that you want at that specific time.
Yeah, and I guess worth noting that the people who have to deal with all of this mess are people who least want to. So they, whether they can or not, they are not the people who are like, enjoy dealing with the infrastructure complexity. They want to just focus on writing the training or inference logic, and it works really well on their machines, and they're like, okay, it's time to scale, and then they hit all of these roadblocks, and it ends up slowing down, rolling out new models and new experiments, and all of their business get affected by just the fact that these machines are not available.
Yeah, I remember a data scientist saying, I just want to make machines smarter. I don't want to worry about infrastructure or all these kind of things. I just want to make machines smarter.
I like that. That's a good goal.
100% agree.
I think the question then becomes, can I use on-prem? I think we've seen a massive shift just in the industry for everyone moving to the cloud, right? Let's go to the cloud. I remember when I was working in the world of application performance monitoring, I would sit down with CIOs in Australia and they would say, we're going to the cloud. How can you help me with this? And it was 2013. Cloud cost management didn't really even exist in 2013. I think you could get your billing data through a CSV, and you had to scrape that and then pull it into a BI platform and go from there. I think we've come a really long way, but now I think people are questioning, does it make sense for any workload, and is it even achievable? So I like to use Google. I decided to figure out how much would it cost me to build a server with 8 A100 cards in it, and what would that look like? So I went to Dell. This is just list price. There's no wizardry here. R750 plugged in 8 A100s. I didn't do much more than this, and that's the price that came up. I don't think that's an unrealistic price. I think people can go and negotiate. On the screen next to it is a very random OEM vendor that just, I think, will send you all the parts and you get to put it together, a bit of a science experiment, just to show the lower end. I think these are realistic investments. If you're going to be spending, money with AWS and you're thinking, well, I can't get my resources, that's going to impact my ability to execute. Can I do this? Yes. And I think the hardware is available. I'm not hearing people that are sort of saying, hey, I need to use, switches to spin up a new data center that are 2 years old that I'm pulling out of my storage racks that were, made for backup anymore.
I'm a bit curious to know what's the lifetime on these. Do you run through these every year, or do you is this if you really get utilization up on that machine, how long will it last?
Do you mean like the componentry?
Yeah.
Yeah. I can't speak for an A100 GPU, but I mean, if you're talking to Dell, I mean, they're selling these with 5-year support and maintenance contracts, right?
Okay.
Their hardware will dial out, and you'll just have a technician rock up at your co-location, your data center. They'll knock on the door and say, "Hey, there's a drive that's dying. I need to come and fix it." I did work for Dell for a few years in their software business, and had the pleasure of working side by side with their teams. And this is stuff that they really do. In the market, and there's vendors out there that will do extended support, so you can push it out to 7 years and things like that. So I think it is realistic to get to 3 minimum.
So when we look at these numbers, we should think about this divided by 3 really to do a fair comparison with the cloud prices. Yeah,
I think if you need to run 24 hours a day, you've got a little bit more ROI calculations that can be done there, right? If you're for on-demand monthly versus something that you're going to be running for yourself. So if we look at ROI, as we're just chatting about, I think this is something that is obtainable, and there are alternatives to spinning up a whole data center. Some recently, who was it that posted on LinkedIn that we're talking about in the office that just got a whole bunch of servers delivered? Hey, the Basecamp guys.
Oh, okay.
We'll share it out. We'll repost it on LinkedIn. They're going back to a data center. They're fundamentally building the whole thing. I don't think everyone needs to go to that level, but there's alternatives out there outside of public cloud that can make this type of stuff happen. So that's kind of how we got here, and we all came together, right? So I think this session we're going to jump into a little bit more of these questions, dive into a bit more of on-prem and how people are actually doing it, what a platform might look like on premises. Chat about our workflow engines, skill shortages, and what people need to get going, right? I want to make machines faster and smarter. Definitely isn't someone that wants to sit there and try to pick regions, but they probably also don't want to have to find a data center, plug in cables and rack and stack and stuff like that. So.
Oh, now I remember. 37 Signals was the name of the company. They decided to go all in on-prem, move every workload out of the public cloud onto on-prem. And they have this great blog. Basically, it shows the ROI. It says they stand to save up to $7 million in the next 5 years, just going to on-prem.
Wow.
Yeah.
I think ROI is one of the topics that people take into consideration. I think, especially being the European on this call, right? We have our GDPRs, our European AI Acts, many regulations going on right now. And I think that's a big part of it as well. Like the whole data governance piece, right? Who owns the data? Who's responsible for the data? Whose data is it? And making sure that you can comply with all of these different regulations, which we have both on a national level and on a European level. That can become so complex that people just decide, okay, let's put it in our own data center. At least now we can guarantee the governance on over that data. And let's be honest, when we talk about AI, we talk about a lot of data because that's one of the most important pieces, right? You need data to train your AI models, and you do inference on data. So that becomes like a big piece of why people are moving out of the cloud as well. But sometimes it's also the reason why they move in to a specific cloud, right? For example, a great example is Germany, where I think Azure, actually, the data centers and everything is owned by a German entity, so that they can guarantee the regulations and everything that is required locally. So there's so many reasons why, but I think data is one of the biggest pieces, and all of the policies and regulations and compliance.
I'm seeing a question here. I think that the main question people appear to have is, how realistic is it to really run AI workloads on premises? Because I guess the flip side of that is you get so many services in the cloud, right? You can go to Azure, you got all these modeling software out there, all the services. Can you replicate that on-prem? How realistic is that?
Yeah, no, I think it's very real, because we actually see it happen. Partially a reason why people are picking on-prem or actually choosing to run AI workloads on-prem is because when you look at the landscape right now, all of the different tools, all of the different, let's say, use case specific tools, they're very focused on running on infrastructure. And I'm not necessarily saying on-prem infrastructure, but infrastructure, and not like in an Azure ML form or a SageMaker form, right? And they give companies the flexibility to build the stack that their specific AI practitioners need. And that's why we see a lot of people actually running it on-prem, because they get a lot more control, they get a lot more flexibility and freedom of choice, because they can build the stack that their AI practitioners require.
I think I would add to that, even we see that even within public clouds, the choice of the infrastructure tools and your tech stack, people really err on the side of like cross-cloud tools or open source tools and things that, even if they don't really plan to move across clouds, they would rather pick something that will allow them to. And that really gave the like a push needed for all of these tools to work, to be very agnostic to cloud services. So they don't care about the cloud, they might as well work on premise, right? If you set up your own data center. And it gives people really the freedom to pick the right infrastructure for what they really want to run. And then we see a lot of I don't think it's like a binary choice. We do see a lot of people who do like hybrid setups where they run some workloads on premise, probably, as we were talking, for cost reasons, if they pick machine or availability of GPU machines and so on, while running the more like commodity services, I guess, on public cloud for other purposes, right? You get high availability. There are some very attractive features in public cloud that engineers have spent countless hours perfecting, and just replicating that on premise may be cost prohibitive and time prohibitive. So you can get sort of the best of both worlds if you pick the right tech stack and the right combination of tools.
So that begs the question, Haitham, what are the services or tools that you can easily run on both on-prem infrastructure as well as on the cloud, without getting quote unquote locked in or getting very proprietary with the cloud service? Can we get a little more specific on the AI side and the ML side?
Well, maybe we should start from like right above your machines. What do you put the first thing? And like your OS or whatever. And I think people now, at least the past 6-7 years, the next tool of choice is a Kubernetes cluster, because it gives you a lot of the infrastructure primitives you need, running services and deployments and scaling up and down and so on, right out of the box, without having to code against a specific cloud or services. So they start with that. We see, you can get a Kubernetes cluster on AWS, GCP, on premise, and some differences, but for the most part, they look pretty much the same. We, as an ML infrastructure company, I would say that the piece we see people use for running ML training workloads is Flight. It's the next piece they talk to us about. Once they have a cluster up and running, then they want to run an orchestration tool, because then they can get their practitioners really out of the infrastructure coordination play, and they can just focus on their writing their training code or the logic for like querying data, transforming data, and so on. And they leave all of the business, I guess, of running and choosing the machines, scaling them up, bin backing, coordinating between different practitioners, queuing, like all of this. It just all offloaded to the tool, and it's again agnostic to the infrastructure. It just needs Kubernetes cluster. Where we see some friction, I would say, is where the data is, right? So if your data is maybe in a 3 bucket or a GCS bucket, there's a very high cost of moving data out of these public clouds somewhere else to do training. And we're talking about deep learning or any of these in billions features. We're talking about huge amounts of data that are just going in and out of data centers, and that does add up. So like aside from compute, that becomes a consideration. How many times would I have to pull this data set and train a model and push it back and so on. But yeah, if you like figure that part out, and there are tools that, again, open source tools that make this slightly easier. Things like Minu that will abstract away whether I'm talking to real S3 or this sort of replica of storage. There's like Luster, and you get caching, so you don't have to hit, even if you're training on the same data set many times, you don't have to really keep pulling data out of a real bucket every time. And what you end up with as a practitioner is I'm running my code that runs maybe on my machine on like smaller data sets, and as soon as I'm like, this looks right, and I want to run on a larger box or on multiple boxes and running distributed training jobs and so on, I would just submit the same code to this service that my infrastructure team set up, and I don't have to know maybe the GPU parts of my job are running on premise, and the CPU parts, or the things that don't really care about GPUs, are running in the public cloud, and the infrastructure is taking care of moving the data, and they end up with the model at the end of the training job, and I can put it back on my machine, can do some validation and so on. It really accelerates that cycle and lets people ship models really quickly. We saw started flight at Lyft as I think we talked a lot, Chris, about this before, but yeah, just people who don't know flight, we started in 2019, I would say, at Lyft, and it's running all of the Lyft ML and a bunch of ETA jobs, pipelines there, and we saw a big shift in how frequently ML practitioners ship models and changes to models from before and after introducing a tool like Flight, or that takes care of orchestration. Even though Lyft is running all in public cloud, and there's a lot of availability was not the problem, but the coordination across teams and across the the resources available to the employees was an issue. And once you take that away, the velocity of these ML engineers just shot up. So months to deploy a model to a couple of weeks, and that just as a business improves the how fast they can move in the market quite a lot. And we're seeing that experience replicated in a lot of other companies in different sectors. Hopefully we'll get to talk about some of those in a minute.
That next layer that I don't think many people think about, if we've gone from months to weeks and there's availability of compute, then how do you maximize, right?
Yeah.
I think a lot of people might look at Kubernetes and sort of say, does it do that automatically? Is it built in? Is there optimizers there for it? I think Kubernetes is fantastic for scaling up. There's a lot of businesses out there that might say, we kind of have to hit it with a bit of a baseball bat to get it to scale down at the speed we want to, especially in cloud. They can end up with a lot of resources that hang around for longer than needed. The more expensive that machine is, and you multiply that by 365 by 7. by 24.
Yeah.
That can be a lot of money. So if we can get a better throughput on any infrastructure, cloud or on-premise, that's a huge gain. But if we can optimize another layer again and get a higher level of parallelization, which is a word I swore I'd never say on a webcast, it's got to really push up that return for the business, and it has to be delivering a better agility to the market.
Yeah, which is actually the question that's coming up here. Given the cost of these GPUs, whether it's on-prem or in the cloud, how do you maximize the utilization of those resources, right? It's one thing to go fast with your engineers to get stuff out, but it's also important to look at the cost of what you're actually spending, right? To get that value out of your models. So maybe the question here for the team is, how do you maximize the utilization of your, especially the GPUs?
Yeah.
You know, what are some techniques that are out there?
I'd love to talk about that, because I think we talked about the data gravity piece, right? And how to get the data there. And there are many beautiful solutions there. And like you said, Kubernetes is great. And I always like to say Kubernetes is great for scale out. If scaling to like large microservices applications, no worries whatsoever. But if you look at the way AI applications are, let's say, developed, there's a very specific, well, I say very specific, but there's a process, right? This starts the development where data scientists, they start coding in their Jupyter notebooks and on GPUs, and they're doing experiments where they don't always necessarily need like a full GPU, but most of the times, because Kubernetes, like I said, was built for microservices, not necessarily for AI workloads. So Kubernetes can give you a micro core of a CPU to a container, and then if a container needs a GPU, ta-da, there's the full GPU. And that might be a waste. But then we go from experimentation into training a model. And training is like a large workload, right? That's where they typically use a full GPU, multiple nodes with multiple GPUs, or they have to scale, which is way more of a scale up kind of approach, where we now have one pod, maybe even consuming like a full node worth of resources. And that's also not necessarily what Kubernetes is built for. I heard Hatham say bin packing, right? That's kind of a thing that Kubernetes out of the box doesn't support. Also, when you look at all of these different data scientists needing different notebooks on top of running on pods, on nodes, on GPUs, or maybe even pieces of GPUs, because there's technology out there to actually share a GPU with multiple workloads. It's a very interactive approach, and there's people requesting resources all the time. Kubernetes by default has a single queue. So one data scientist gets in the morning, fires off all of his jobs, and on all of the GPUs that are available, wonderful, they're done. So there's no fairness built in. So if you want to optimize the experiments and experience, not experiments. Sorry, not native English speaker here. I won't even try the P word that you just mentioned, because I will definitely trip over that one. You need to augment Kubernetes, right? You need to, and luckily, because Kubernetes is so open and has like scheduling frameworks that you can tap into, you can actually make it like a platform for AI workloads. And that's kind of what we've been doing at Run AI, where we've really tapped into that scheduling framework, where we've added our own actually AI workload scheduler that adds multiple queues, adds priorities across those queues, adds gang scheduling for this large scale training workloads, adds batch scheduling with fairness algorithms, so you can actually make sure that all of your teams can get like a fair amount of resources. Combining that with what we call GPU virtualization technology, where we can actually take a GPU and slice it into whatever you need. Is it 1 GB of memory? Is it like half a GPU? It could be really flexible. And combining those two methods, make sure that you can get the most out of your GPUs, because maybe you want to run 10 notebooks on a single GPU. What we see is when you don't add all of these things to Kubernetes, and especially because GPUs aren't really considered like a first-class citizen in Kubernetes, we see low GPU utilization. And that's like resource waste is a big thing right now. With environmental impact of AI is definitely something that people have been talking about right now. And if you only use, let's say 20%, and that's what we see way lower numbers, but let's be nice and say there's an average of 20% utilization. That's like a huge waste, not only from an ROI perspective, but also from a like sustainability perspective.
Yeah.
And that's when you really need to take into account all of those different stages, like model development, model training, inference, which doesn't always require either CPUs or a full GPU, and make sure that the platform understands the different workloads and understands how GPUs are being used and use them in a very flexible way. And I think that's kind of the next layer of optimization, right? How do I get my workloads to run in the most efficient way, utilizing those GPUs in its full extent? And utilization is one piece. The other piece is all of a sudden, now you have more GPUs available to your data scientists, so you can add more data science teams. And again, data scientists, they want to make machines smarter, and they want to change the world with AI. They don't want to worry about, oh, let me log into the system through SSH and see if the GPU is available. They don't want to worry about those things. They just want the resources whenever they need it.
As we're sort of getting ready to host this webinar, I think, Gijsbert, you mentioned a really unique use case that I think touches on that utilization piece. You said there was a computer vision company that you've been working with, and they return all their vehicles to a single location overnight, and then use that workload, that processing power that's in the vehicles. Is that a real thing?
So there's I can't name any names, but there's a company that has autonomous like little vehicles that all have I can't remember the real an NVIDIA RTX something. And every at the end of the day, they pull into their docks. They get like a 10 gigabit connection to the network, and they're basically doing nothing. So the company was thinking like, what can we do? Can we utilize those machines who are running actually Kubernetes worker nodes? Can we connect them and use them somehow? And that's when they looked at like, okay, how can we use that and scale training and do training at night, retraining our models on those machines? And that's a very interesting use case. But you need to have something in place that understands how to run it, how to schedule it, and basically automatically do all the workload management on top of it.
That's almost like Edge, bringing it back together.
Yep.
And it hits on all the things. Like that's improving your return on investment. That's being much more sustainable with the use, right? You're not wasting anything that's just sitting there, and it's increasing the agility of your business all in one. I was talking to a supermarket chain here in the US recently, and they were telling me about what's going on at the checkout, and especially the self-checkouts. And, there's nefarious activities. Everyone's seen someone scan something, but put something different in the basket. And, I think when they first launched, all these companies said, you just put a scale where the object goes down and the barcode knows the weight of the thing, and the weight's off, then the red light turns on, but then everyone just got stuck, right? They'll put a bag there and the queues ended. So I think globally, supermarkets turned it off. And it would appear that they're moving to computer vision. So they have cameras that are running, taking that video and trying to detect nefarious activity. And they're saying that the next generation of this video platform that's watching self-checkout actually requires an NVIDIA GPU in store. And I don't think it's going to be an A100, right? It's probably going to be more of a consumer grade card because it's doing inferencing. But then it opens this question. Okay, now we've got it at the edge. This is a completely different thing. How do I increase that and get more value? Right? I think there's options for being more creative with that compute in store. Maybe larger chains could start thinking, well, can I do a bit of distributed training maybe, or is latency going to impact things? But it's really gets you thinking, what can I do with this compute now? I've got it in all these crazy and wonderful places.
Yeah, there was a question actually here about edge use cases. This is now that Chris brought it up. I mean, we see retail, manufacturing, oil and gas. There's so many different industries where there seem to be interest, or at least people are talking about it. What's your experience? Are you seeing anything real? I mean, is business being conducted with ML at the edge? Can you talk about those?
So I can't also name names, but we have definitely seen use cases where people, especially inference, is what we see very common on the edge. We see a lot of training, of course, happening either public cloud or on premise, and then some automated process where models get pushed to the edge and inference run there. But then there's an interesting sort of feedback loop that comes back from these computers to influence the next iteration of inference. To utilize this for metrics and monitoring of the models and so on. And that part is its own infrastructure, just collecting data from efficiently from these machines and being able to aggregate and do privacy preserving practices. It's a very, maybe has its own webinar to talk about. But yeah, no, that is definitely an interesting use case. I think what I would use cases like a Tesla car, or one of those maybe more powerful computers that are on the edge that can potentially do even live training in the car would be an interesting avenue to explore. We haven't yet seen those, but yeah, the common case, I don't know percentage, but we do see that a lot. Training happening in the cloud and inference on the edge. One thing you mentioned about I think utilization, and we've seen that problem a lot everywhere I worked. I worked at Google for a while, and I think Meta or Facebook does the same. There is a common practice in these bigger companies where there's always budgets, right? These companies own their own data centers, right? So they're both limited by these machines, but also there are a lot of them. So they give budgets to employees or to teams, or even bonus budget of sorts, compute budget to run when they're off peak hours. And it's a very good use case for training workloads, because you're not really constrained, but I don't really need the thing to run immediately right now, right? But I want my part of the job as an ML practitioner to be done. I will submit the job, and I want to know when it runs and get back the results, right? I don't care if it gets immediately scheduled or not in a lot of cases. So if you can maximize utilization by scheduling these sort of lower priority jobs, or maybe preemptible jobs off peak when utilization is lower on services, clusters or services, servers, you get really higher utilization, and we get 80s, 90s with a lot of constraints, right? You have to know that this workload has to be able to checkpoint, and I can preempt it, move it around. It adds some friction there. Though I would say in the recent years, even those have become a lot better and a lot more automated, and you don't have to really think about it as an ML practitioner. So auto checkpointing, all of the infra, or the ML, PyTorch and TensorFlow and so on. I can just hook and record a checkpoint, and then you move it somewhere else, and it starts immediately where it left off, and you don't waste resources and so on. So that got a lot better. But yeah, we are seeing a lot of like ways people go to maximize utilization. We were able to get to, don't remember numbers, but like 50% utilization on machines previously, where we were seeing like 20-30% utilization. And just that's like double the utilization. Even when it's like below 50 or around 50, you are still maximizing or I guess lowering the cost by half, which is huge. And imagine if you push this 20 more percent, as maybe some of the tools we talked about, or like some of the innovations you can do on the scheduler and so on in Kubernetes can bring you. Yeah, so it's definitely interesting space, and the ROI on these machines can improve quite a bit.
Yeah, I like the bonus piece of it. That's a very interesting one, because I jokingly say in like to customers and in sessions, like an idle GPU is the most expensive GPU in the world. And you paid for it, you're paying for it, but nobody's using it.
Yeah.
That's kind of like a technology that we use as well, is where we say we call it over quota. So you can give a project a specific quota of, let's say you can use 8 GPUs at any time, but we enable over quota. And that basically enables teams to use more than they're entitled to use, because it turns out, oh, those GPUs are not being used. So why not schedule that training workload that's waiting somewhere on those GPUs that are currently not being used in an automated way, and then the training gets done faster, right? And that kind of takes you to that 50, 60, 70, 80, all the way maybe up to 90% utilization, just by using the resources in a smarter way. Because again, you don't want idle GPUs. You want to avoid those. You want to get the most value out of your GPUs. And like Haitham said, if you're using 20% and all of a sudden it's 50, that's like double the value. And all of a sudden you go to 80, that's like 4 times the value. So you keep adding, and those are things you have to take into consideration as well. I think removing the complexity from the AI practitioners, like really, really important, because that allows them to focus on the things that they want to focus on, right? Achieving those business goals, working on those business cases, making machines smarter. But then we need to give the people that build the platform, IT, DevOps, platform engineering, I don't know what it's called nowadays. But you have to give them the tools to have like the control and visibility over all of those resources, regardless of where they are, to make sure that they can get the most out of them. Yeah. And I think those two worlds, they speak different languages, but they need to come together. That's kind of, you mentioned glue. Yes, I think we need a lot of glue to make sure that we can stitch all of those things together.
There is a question here real quick on that topic. We hear a lot about self-service for end users, right? For developers, for data scientists, for modelers. And often, and Chris and I have seen this a lot, is people are waiting around for things to be provisioned for them. Hey, I need a GPU. Okay, I'm sitting here twiddling my thumbs for someone in platform engineering or someone from IT to give it to me, right? And this is the whole reason why people went to public cloud, was because they were waiting around. We said, you know what? I'm tired of this. I'm going to the public cloud, swipe my credit card, boom, I get my resources, right?
Yeah.
But do you see what's happening now with this whole self-service thing? Because that's a big, time waster, if you will.
It's a very interesting piece, because I don't want to pitch like our own research, but we've done a survey about the state of AI infrastructure, and one of the key things we saw there is that most of the organizations that we talk to are using public cloud, yet 70% is still not having on-demand access to GPUs, which is kind of like that's
even in
weird.
A public cloud, even in a public cloud,
even in the public cloud. And I think the reason why is because of all of the things we actually talked about right now. It's because they don't have that self-service provisioning. They still have to talk to the team that actually manages the platform inside the public cloud, and there's a disconnect there. And the closer we can bring those two together, those gaps, those challenges are gone, because self-service is very, very important. As long as it's tailored to the end user, right? An AI practitioner, they don't want to know anything about PVCs, and they don't want to kubectl their way to creating a pod. They want an easy way, whether it's CLI, API, or UI, to get to the resources they need using the tools they need and they prefer. And I think that's kind of the thing we need to do as like all the different companies, is bring those all those different expertise and different things together.
That's a question for you, Chris, because you see this a lot, right? In the customers and prospects you talk to about solving this problem. Can you speak to that, to how people are addressing this issue?
Yeah, I call it the to PaaS or not to PaaS. And I think there's a lot of companies out there that are looking at, like, from a developer perspective, right? Sort of outside of today's topic on AI ML. How do we enable developers to work quickly on cloud native? So Kubernetes infrastructure. It's an area that we've been focusing on. if we go and look at people like Adobe and Intuit, they've got creative ways of bringing together CI/CD platforms. So then developers are literally just committing code, and then from that point onwards, it just goes and it's all automated in the background. I think when some people look at workflow tools, it's sort of not a dissimilar type of experience. If I've trained a model, cool, how do I then get that into production running an inference? It's probably going to be using a CI/CD platform and some form of automation. Others are going the complete opposite, right? They're going so far away from Kubernetes that they're building a complete PaaS on top. And there's a lot of large financial institutions that have, 10,000 plus engineers that have done that. They've built layers where they're kind of abstracting away from Kubernetes again and again. I think it's going to be in flux and change for a bit. I think from a dev experience perspective, I think it is possible for engineers, they're smart people, to understand how Kubernetes and applications get glued together. Moving to data science, I think that's a thing that should just not be asked, because it's the resources required are different. And as was mentioned, they're not first-class citizens. So how do I even write a Kubernetes manifest to generate a pod that can say, hey, I want this much of a GPU or this much RAM, or how do I get a better level of bin packing? I think they're concepts that are maybe fine for a developer to think about, because their goal is to be optimized, right? You don't want your app running crazy into consuming, nodes and nodes and nodes unnecessarily, right? You want a different form of efficiency. I think moving up the stack into data scientists, that's a bridge too far, as people will say.
Yeah, one I guess another interesting question along the same lines is, you give all this, self-service power to the end users, and they go berserk, right? And then the governance question comes up, right? The two questions that come up here. So I'm seeing here one question around governance. How do I make sure you don't have runaway containers or runaway workloads where, one team is hogging up everything and everybody else is kind of sitting and twiddling their thumbs? It's also an inefficient way of utilizing your infrastructure. That's one question. Another related question is around what happens when a job, I'm assuming, Haitham, you see this a lot, right? You're running these complex, long, pipelines, training pipelines that may take days and I don't know how long. But what happens if something just blows up, along the way? And it could be a pipeline issue, it could be an infrastructure issue, it could be, storage not being available, it could be anything, right? How does cloud help with this, or are there tools that address these kinds of issues?
Yeah, no, I think on both points, I think you are hitting a real pain that people see when we don't have the right abstraction layer on top of Kubernetes or running jobs. You start having to deal with, it's even worse in ways. It's worse than saying no, you have to use Kubernetes directly, kind of thing, because you are abstracting some parts, but not a full picture. You don't get the right monitoring. You don't get the right controls over what happens when things go wrong. So you find yourselves jumping between two worlds, kind of thing, and it's really confusing again for people who this is not really their priority or should not be their priority or skill set or expertise. So we heard that a lot in working on flight, that monitoring is the biggest piece that people kept asking about. It was like, okay, my thing is running. I can trust the platform to do the platform level monitoring, I would say, on the workload. So making sure things either run to completion or they fail and get cleaned up, how they get retried and checkpoints get transferred like that. That's something the platform can guarantee for an ML practitioner that Kubernetes cannot, because Kubernetes has no understanding of well, this workload is related to this other workloads, or I need to data transfer between this and that, or even I need to co-locate things on, similar on the same rack, or I need high throughput between them, or things like that, right? This is where you can customize a scheduler, and that has add gang scheduling, or add something that to say, well, I know that these two things or 10,000 things need to be co-located. So I will take care of picking the right nodes and the right infrastructure to schedule them. And subsequently, you can also say, well, when this fails, I know that I can retry this. This is safe to retry because it checkpoints, it's doing all the important operations and so on. Whereas this other workload is, if it fails, this is, I should not touch. I should just surface that, maybe page someone, the mail practitioner and so on, because this is, it's unsafe to retry. Right? Again, these are all constructs that are not really native to Kubernetes, but just are intuitive for an ML practitioner when they expect to come from a service. Also speaking about self-serve. The monitoring then becomes your next, let's say, weapon or a tool to really improve both utilization and really efficiency in running your workloads. You want to know, well, my pipeline overall maybe got a score. If it exceeds the 50% of the norm utilization we're seeing across the board. It also monitoring works both ways. I can see where the bottlenecks are. Maybe if I give more CPU to this, workloads, it can run faster because I'm hitting the time, getting throttled a lot on CPU. Or if I give it more memory, you get killed. So I need to know when do I hit that threshold? Maybe I don't need all of that memory in the beginning, but I need that halfway through. So I can really get or distribute the memory consumption or allocation in a different way so that I can get my job done, but at the same time not hog resources for unnecessarily long hours or days at the end. Again, these are not constructs that come native. There's, at Kubernetes, you can get pod level monitoring, node level monitoring, but there's you can't really correlate these with my actual Python code that I wrote to do training. So having a tool in between, in our case, Flight and Union, where we can surface all of this in a, give you insights about your workload that sort of speak your terms, the code that I actually wrote and the pipeline I defined, and giving you the data at that point helps people really quickly optimize their utilization and consumption and velocity of running their workloads.
Yeah, we are almost at time here, a couple of minutes. I think maybe we just wrap up, Chris, here. I think the main thing that I'm taking away from this discussion is the most important thing I heard was let's abstract all the complexity of the underlying infrastructure, the utilization from the end users. The data scientist does not want to go in there, do kubectl their way into what's happening. That's just not productive use of their time, right? They need to focus on their business, on running the models. So that's one. The other thing I'm hearing is it's not just, there's a lot of on-prem too, but it looks like it's going to be more of a multi-cloud, hybrid, on-prem, a combination of all of that stuff, which essentially means that we need to not be dependent on any one particular public cloud or any one particular thing. So abstraction is going to be pretty critical to be successful, right? And plan for that right from the beginning and use the right kind of tools. Kubernetes obviously helps with the abstraction layer. Tools like Flight that Union is working on also help at one level. And then Run gives us the ability to look at what's happening from an infrastructure utilization point of view. And hopefully that also helps across all the infrastructure, right? Iceberg, from a Run perspective, it's not just isolated to any one particular environment. So all of this helps you to become ultimately agnostic, right? Really, that's the goal of this.
Yeah.
You want to kind of wrap up and say a few words before we close the session here?
Sure. Thank you, Heisberg. Thank you, Haitham. This is enjoyable from my perspective. I think a lot of people out there in the industry are looking to learn and grow and improve, be more efficient, or maybe people are just looking to get going and say, let's hit the ground sprinting, and how do I do that best? And I think we touched on some good topics today, and really looking forward to continuing this more in the future.
All right. So we'll have hopefully a follow-up session to actually show you guys how all of this stuff works. Right. It's one thing to talk about ROI and expenses, which is important. We all want to save money now, given the situation we're in, but it's also cool to see how the tools and technologies work. So hopefully pretty soon we'll let you know, but we'll have something to show you.
Awesome. And thanks again for organizing this and for having us.
Thank you so
absolutely.
much.
Thanks a lot. Looking forward to the next session.
Yeah. Thank you, everyone that joined. Hopefully you found the session insightful, and stay tuned for more. Thank you very much.
Thank you. Take care. Bye, guys.
Thank you.
Bye.